Welcome to solverfy.
In this problem, we have three electromagnetic waves that are converging at a point, and the equations of the electric fields at that point are given as the first electric field follows the equation of 10 microvolts per meter times sine of omega t. Second electric field has the equation of 5 microvolts per meter times sine of omega t plus a phase of 45 degrees. And the third electric field has an equation of 5 microvolts per meter times sine omega t minus a phase of 45 degrees. And we're told that omega is 2 times 10 to the 14 radians per second. And what we want to know is what is the equivalent electric field, call it E total, which is just the sum of the three waves, of the three electric fields. And we want this to be in the form of A and then sine omega t plus some phase. So how do we add this up? Well, these can be added up as by adding up phasors. So a phasor is just a vector that goes around in a circle, and it's got some magnitude A, and it's got some, let's say at t equals 0, it's going to be offset by some phase phi. And that actually doesn't change. These are just constants. The rotation comes from this omega t part. So if we look here, all these are sines. They're all something times sine omega t. And that means that these are all just adding up the y component of this vector here. Right? This has a y component, x component, and these e fields are just adding up the y components. So how do we add these up? Well, what we know is going to be constant is the offset phase and the amplitude. So what's the amplitude of adding up a vector? Well, first let's write down what this vector is. This vector has a y component, which is just going to be the three. We'll just write it as E1 plus E2 plus E3. All right, and that's all these sine pieces here. Where the x, well, it's the same thing, but it's going to be with cosines. All right, so I guess I should just probably write it out. So E1 was 10, and I'm not going to write the units. The units for all of these are microvolts per meter, so 10, and now it's going to be cosine omega t plus 5 cosine omega t plus 45 degrees and plus 5 cosine omega t minus 45 degrees. Right, and the E1s are just the same thing but with sines instead. So the amplitude, let's do the amplitude squared, is going to be the sum of the x's squared plus the sum of the y's squared. And since it's the same at all times, we can just set t equals 0. So that's what you have to do here. Set t equals 0. All right, so the x's squared is going to be 10 times cosine of 0, which is just 10, plus 5 times cosine of 45, which is 1 over root 2, and then plus sine times cosine of negative 45, which is also 5 times 1 over root 2. And that's squared. Now we do the same thing for the y's. So the y component is the same thing but with sine, so that's going to be 10 sine of 0, which is 0, plus 5 times sine cosine of 45, which is times 1 over root 2, and then plus 5, and then going to be sine of negative 45 degrees, which is negative 1 over root 2, and that's squared. And it actually works out nicely. These cancel out, so all we have is the x component. So we can just square root right away to find that a equals, well, 5 over root 2 plus 5 over root 2 is 10 over root 2. So there's a 10 in front of the whole thing. So this is 10 times 1 plus 1 over root 2. Now we have to find the phase. Now the phase is given as the tan inverse of the y component over the x component. Right? Well, the y component is 0. So this is just 0. So there's no phase shift. So now we can write that the whole thing, E total, which equals E1 plus E2 plus E3, we want to write it, remember, in this form here. We found what the phase and the amplitude are. Well, the amplitude is 10 times 1 plus 1 over root 2. Now it's times sine of omega t plus phi, where phi is 0. And this equals, if we actually plug in the numbers and put the units back in, this equals 17.1 microvolts per meter times sine of, and omega was 2 times 10 to the 14 radians per second times time. And this is E total.